So hello and welcome back to part B of the course, and we'll be starting this part with evolutionary techniques. So just a vision where it is going, we saw that for interesting behaviors I could write down some programs, the programs which make a lot of swarm robots come together at one place, or aggregation disperse at different places, a robot doing a lot of things simultaneously, but I need to write down those programs. What if I try to imitate the natural life, and by imitation of the natural life, I say that did somebody program me? No, I came to this world and I start acting in this world, and by merely acting in this world, I wrote down my own programs using which I am taking this part of the lecture. So why should anybody program robots? Why cannot I have robots which automatically evolve themselves, which automatically do interesting things with whatever they come to this world with whatever sensors, actuators they come to this world with, and that will be our long-term vision. And apart from that, of course, so the humans, they evolve with time, the species evolve with time, the animals and plants evolve with time. So let's study that and make interesting algorithms known as the evolutionary algorithms or the evolutionary techniques. Primarily, I'll be focusing in today's lecture on optimization alone. So I'll say that there is some problem which is given to me. So let's say f of capital X is equal to 20 times x1 minus 30 the whole square plus 30 times x2 minus 25 the whole square plus 28 times x1, x2, x3 plus 5 times x3, x4. So that's a kind of expression that I need to optimize, where x is of course x1, x2, x3 and x4 as an input, and that's the expression that I need to optimize. So let's say that I need to find out the x which minimizes this expression, and there will be some constraints. So to make it simple, the constraints could be linear, non-linear, equality, inequality. Let's have the most basic constraints that all my variables will be between a lower bound and a upper bound. So I only have bound constraints. I will not be taking in any kind of other constraints over here. And of course, the entire way by which this is optimized, the entire way by which we solve these kinds of problems is into the other course which is going on parallelly. So let's clarify the title. It is a very quick recap of evolutionary techniques. It's all a soft computing course, so I won't be taking it into an entire detail. So what I'll be doing is I will be solving this problem and trying to get what is the optimal x possible which minimizes this expression. If it was a typical mathematics course, I would have taken the gradient and I would have moved in the negative direction of the gradient and gone to the optima. But it is a course on evolutionary techniques, not always do all functions have a gradient which is possible. So I'll go on with evolutionary techniques to solve the same problem. So I'll say that in the evolutionary class, I have a population, and this population has a number of individuals where an individual is x1, x2, x3, and x4. So it's x1, x2, x3, and x4. So as an example, I could say x1 is 5, x2 is minus 2.8, x3 is 2.9, and x4 is 8. So that's one individual in the entire population. And once I have got this individual in the population, what do? I find out how good this individual is. So there will be a fitness function, a function which says how fit or how good this individual is. Now, technically speaking, the term fitness is used for something which is good. So it's used for, typically it is used for maximization problem. And here the problem is minimization. So sometimes I use the term called as a cost function. Cost is something bad. You hate giving bills of internet to watch videos like this. So cost is something which is bad for a minimization problem. Our problem is minimization. So more correctly, I should be using the term cost function. However, it's not a formal course on evolutionary techniques. It's just a recap course, and therefore I'll be using the two words interchangeably. I'll say fitness and cost interchangeably, and I'll let you know whether it needs to be maximized or it needs to be minimized instead. So we'll do the adaptation when I am speaking. So I have a fitness function over here that says how good or how bad an individual is. I can put in x1, x2, x3, and x4 over here and find out what is f of x. Let's say xi, because it is one such individual of the entire population, and that can be calculated. Now, because we're dealing with evolution, I'll say that imagine this is a world. So it's an ecosystem. It's a society where different individuals live, and fitness is how good or how bad the individual is. Like for this course itself, there are students who are performing extremely well, extremely fit individuals, and there are students who obviously are not performing that great. So they are weak individuals or they are poor individual. In a natural sense, the coronavirus pandemic is still going on as I record this lecture. That's why I have to take it online. So there were people with great immunity system, they were good, and there were people with poor immunity system, they were weak. So everybody has a goodness or a badness. Now the goodness and the badness is typically the goodness or the badness of your chances of surviving in the particular ecosystem or in the particular world that you are into. So in this world of this course, the better the individual, the more likely is the individual to pass this course. The weaker the individual, the most likely the individual is going to die off, flunk this course, and will have to take it up again. in the pandemic, people who had poor immune system, they eventually, unfortunately, could not survive, even though there was a lot of science and technology available. So, goodness of the individual is how likely is the individual going to survive in this world. So, fitter individuals are most likely to live, and the worse individuals are most likely not to survive. And it has been going on historically. So, many species you don't talk about today because they may be great species, but they absolutely could not survive. So possibly the dinosaurs were very powerful animals, but then they weren't great individuals of the time because animals need to feed, and what good is an animal that cannot survive on the kind of food that is available? So depending upon the situation, they just couldn't survive. Similarly, you talk about, as we talk in, there are insects flying around over here, and most of them die. So most of them are unable to survive because they're physically not able to fight the predator. And with all the technology that I have got, and I use all the mosquito repellents and all the advanced technology, they cannot survive that. So the weaker individuals, they are not able to survive. And it's also temporally dependent. So along with time, there are individuals who once would have been great, the dinosaurs, but then the situation changed, the problem changes, and for the new problem, for the new world, for the altered world where there's little food available, they just cannot survive. So humans were great, and of course we are still great. The humans were doing absolutely great. But then the problem changed, the pandemic came in, and nobody anticipated that. As for the new problem, many individuals were not doing great. So the problem changes, and who were once great people, they are no longer great. After this course, you will be doing another course. And many people who survive this course extremely brilliantly will not be able to survive the other one. So that's something that's natural with the natural world, and that's what we take an inspiration from and try to inject it into artificial algorithms, that the cost function or the fitness value is the goodness of an individual. Good individuals, they survive, and the poor individuals, they do not survive, and this process is called as selection. So let me name everything up. We discussed individual, population, cost function or the fitness function, and now we're discussing selection. So selection is the unfortunate rule of the world. So it says that fitter individuals survive, and weaker do not. And let's make it stochastic because the natural world is extremely stochastic in nature. So sometimes you see extremely weak people and they survive quite a lot. Sometimes you see extremely weak species and they survive a lot. So are more likely to, and the weaker individuals, they do not survive. And therefore, let us say randomly from this population, let's select some individuals whom we say are probably going to survive either because of luck, or they are going to survive because of the fact that they are actually very good, they are fit. Now once this thing happens, once selection happens, now what you really do is that you go and in this beautiful, lovely, romantic weather, you, at least from where I am teaching, the weather outside is brilliant. So you mate and you reproduce and you produce more of your kind, And that one is what is called as a crossover. So the selected feather individuals, they mate, they cross over, they breed, and they produce children. Now, the children always carry some characteristic of the father and some characteristic of the mother, because we're dealing with digital life. We are dealing with a simulated environment, so there could be multiple parents, any number of parents producing multiple children, any number of children, and the entire operation is what is called as a crossover. So let's say that these two individuals, they generate some children, and these two individuals, they generate in some more children. So the circle ones are the ones which are in the world right now. They got selected, and because they got selected, they are producing children. So let's produce in more children. So these two mate and they produce in children. So lots of children around over here. Now, here also it doesn't happen with human beings, where we have not really emulated nature, but in the other animals, what happens is the fitter the individual, the more reproduction it does, and the weaker the individual, the less reproduction it does. And therefore, what really happens is the fittest and the best individuals, they reproduce quite a lot, and the weaker individuals, they never reproduce, so they virtually die off without any offspring. They just cannot survive. They are fighting for survival, forget about reproduction. And that can be eventually understood in a different way as well. So imagine that there was a superhero and everybody just loves the superhero. So everybody would like to mate with the superhero, and the superhero would also be like, yes, that it's a cool thing to do. So let me mate with a lot of individuals and let me produce a lot of offsprings. And therefore the fitter superheroes will reproduce quite a lot. And imagine somebody who is not able to survive the cold weather. So somebody is not able to survive the cold weather, can barely survive. Person will A, not be reproducing, and B, will not get a mate. So the superheroes get a lot of people to mate with, and the weaker ones, they absolutely do not get a lot of people to mate with. And because of that, what really happens is a lot of children are produced by the fitter individuals, and very few are produced by the weaker individuals. Now, in the process of reproduction, what really happens is that there are some errors in reproduction, and that's called as a mutation. So it's error in transfer of characteristics from parent to children. So that's what is mutation. So what really happens is that you take some genes from your father, you take some genes from your mother, but when the parents are transferring you the genes, when you are as an individual getting formed from your parents, sometimes some of the genes may flip, they may alter, and because the genes flip and they alter, that's what we call as an error. And because of this error, you develop some characteristics of your own. Now, luckily, I'm teaching this thing at exactly the same time. During this pandemic season, specifically right now, there is no other thing which is more discussed than mutation. So the coronavirus germs, the coronavirus viruses were spreading like anything. They were reproducing like anything, and they were growing and like anything and getting transferred like anything. But as the coronavirus parent was producing children, was producing offspring, as the coronavirus was getting transferred, it changed its characteristics. And now you've got a coronavirus which has new characteristics, which has new form because of errors in the transfer of characteristics from parents to children. And therefore, now we talk about new types of coronavirus which are being spread all over. So you've got the UK mutate variant, you've got the South African mutate variant. So you've got all these variants produced as a result of the transfer of characteristics from the parent to the children. So the genes change, the characteristic change. That is what is called as mutation. So essentially what I did was these two parents produced these two children, but they not only take the genes from their parents, they also take some genes of their own, which are erroneous, and that's the one that you see around over here. Now, overall, these are called as the genetic operators. So you can design your own operators. Many individuals may have different type of operators, and because they have different types of operators, you can emulate that up. Like some individuals are unisexual. One parent produces one child at a time, but many children otherwise. Some are bisexual, so one father and one mother produce into children. So different species, they differ in the kind of operators that they have, and therefore you can emulate any one of them. And because it's a digital world, you can have your own rules. You are the master of this world. This world does not physically exist, it's as designed by you. Now what will eventually happen is, if this was a physical real world, these parents who did not produce children, 1, 2, 3, 4, they were weak, they eventually die off with age, and suddenly you'll see that some of these people will not be able to reproduce because now they are not fit anymore and they will die off. It could be either because of age, it could be either because the problem has changed, or sometimes it's a tough world, it's a survival of the fittest. And what really happens is that you may be the heartthrob of the schools, someone whom everybody comes and talks to, and someone who is absolutely brilliant. But along with time, because of all these reproduction, new individuals come in. So it's a competitive world, and in front of these new people, you are no one. And because you are no one, nobody wants to mate with you, nobody wants to be friends with you, because they are much sharper people. And because they are much sharper people, they take in everything, and you can no longer reproduce. And therefore, because of competition, later these parents might become obsolete, they may become orthodox, they may become old generation, they may not be fit anymore, or they are nothing as compared to the new children which are formed, which are way much better than the parents, and therefore they also die off. And that's how the world goes. But then in a digital sense, we say one generation is one unit time, one iteration. So in one generation, if you cannot reproduce, you die off. And then again, I start over with only these individuals, and I say that let me select the best or the fittest individuals. So some parents are still fit because the children that they reproduced were terrible, but most of the times the children are much better, and they are the ones who will reproduce more children. And because they will reproduce more children, and you will get lots of offsprings of these selected children, cross hybrid. And eventually, of course, the ones that did not get selected will die off. And that's how the world goes and improves. Now, if you look at the natural life forms, the younger generation is always much sharper, much better than the previous generation. So I hate to say that you people are smarter than me in many ways. And there is obviously a reason to do so, because the parents, they eventually become an individual which can modify their behavior by looking around, which can see things around and modify the behavior a little bit, but then genetically they are constant. Genetically, nothing is changing. So, genetically, they are locked. Their genes are not going to change. And what really happens is that the world keeps on changing. So the world changes, what they learned previously is not applicable anymore, and the new things they are not adaptive to. That's why old people find it difficult to find jobs. When they started jobs, there were no computer. The newer ones, when they started job, there was no internet. Now, if you don't know how to operate internet, you cannot even take a course in this institute. Sometimes I believe, what if I don't know the latest technology and I'm obsolete for my position? So the world changes. In the new individual, a lot of them are formed, but only the ones which know the latest technology are the ones that survive. The others, they absolutely die off. And because of that, the newer generations, it has good fit people abreast with the latest technology, and poor people not abreast with the latest technology. And eventually only the fittest survive, and out of the survived population, the newer generation is always better than the older population. You could interpret it up in the natural world as well for changing situations. So the different organisms that you see around, so starting off with, once living in sea was absolutely great, but then land had more perspectives, and that's why organisms started coming to land. Then the monkeys were doing absolutely great, but then you need more intelligence, and hence the humans survived. The humans were the modern life forms. So life always evolves, which is more suited according to time. And because life always evolves, which is more suited to time, for changing environments, the new individuals are always better than the older ones. Even if the world does not change, the new individuals shall always be better than the old ones, because of a short reason that the new individuals which come to this world, A, they take in the good characteristics of both the parents, so they're not bad at least. So your parents survived and they could reproduce because both the father and the mother were genetically strong. So first they come from strong parents, and therefore all the genes are strong and they inherit strong characteristics to start off with. And then there are mutation, there are errors. If the mutations and the errors are make the individual better, the individual will survive, otherwise the individual will die off. So out of, again, all the survived individual, the newer generation always has stronger characteristics, and it's definitely better than the parent, because the better mutations are retained, the better individuals are retained, the mutations which result in improved performance is retained, and the mutation that results in poor performance is something that dies off. So imagine that today, two monkeys, they crossbreed, and because of mutation, the newer generation monkeys which are produced, it cannot climb trees. But then, excuse me, if it cannot climb trees, how will it A, feed itself, and B, run from predators? That's not possible, so it's gonna die off. On the other hand, the same parents produce another monkey as a child, and that's even faster in running. Now, in the current monkey population, I'm not sure if increasing the speed of running is really valuable in any sense, but yeah, you can get food fast. Food is declining because of humans eating all the monkeys' food, and what makes it even better is the newer monkeys of this variety will be able to escape all the predators at well as a much faster speed, and hence they'll survive. So who knows that the vaccine has come for the coronavirus, and the coronavirus is producing a lot of individuals as we take this lecture, and the vaccine is soon gonna kill them. But after vaccine comes, maybe there was a mutated individual that till so far was considered by the coronavirus community as lazy, lethargic, not useful, does not move, blah blah blah, but it can survive the new vaccine. And it'll be bad for humans, god forbid that doesn't happen, but the mutated coronavirus will be better than the parent coronavirus because of its resistance to the new vaccine. The old ones will die because of the vaccine, the new ones will unfortunately not die. Of course we'll come out with a new vaccine at no time, and the human race will flourish like anything. Business will be normal. I'll be taking physical classes with you people. So that's in general what's an evolutionary algorithm.